All right, find the equation of the tangent line. Right, sorry, we're doing chain rule now. Hey, chain rule. Hi, how are you? We're going to do chain rule.
Amazing.
I know, right? Okay, so anytime we see equation of the tangent line, we need two things. We need pot and sine. My pot is going to be 2, and I'm going to plug it into here, and we're super smart. So it's 2 over 5, exactly. Then I'm going to find my sot, which means I got to first find my derivative.
Quotient.
Quotient rule, so low,
Low,
d high, which is 1, minus high,
How do you know it's one?
because the derivative of x is 1. High, d low, all over x squared plus 1 squared. Now, realistically, I could simplify that. Who cares? We're figuring it out at a point. So let's just plug it in. 2 squared is 4 plus 1 is 5. 2 times 4 is 8, so negative 8 over 5, 25. So that gets me negative 3 over 25. Gross slope. Gross slope, dude. Right? So then y minus 2/5 equals negative 3 over 25, x minus 2. Woo, we did it.
Super easy.
It is pretty easy.
Easy, easy lemon squeeze.
I love it. Yeah, right? So, you don't really, anytime you guys are finding like the value of it, I wouldn't bother simplifying it. Okay, it doesn't really make sense for you to do it because it just kind of makes your life harder. All right, are you ready? We're going to follow the same format. I'm going to give you one, and we're going to turn it into something else. And then we're going to do the chain rule, so you can see that it's the same, and then we're going to write samesies. Wait, I don't want to. All right, so we're going to rewrite this function in polynomial form. All right, how good are you guys?
No, for you. Don't know what you're asking.
Okay, let's try it. So obviously you could rewrite this if you need to. Let's rewrite it. I think you could do this with the binomial expansion a little faster, but I don't know how many of you guys remember it, so.
You have a plus b cubed memory.
All right, so this is going to be, let's see, 4x squared plus 6, 12x plus 9, because we're smart like that and we can do squares real easy in our heads.
That's not true.
I mean, my regular calculus students could, so I'm pretty sure you guys can. Don't be shown up by the regular calculus. I mean, they get a lot more information than the other calculus
They
class.
don't have to do the exam.
No.
We do.
But you're super smart, and you like the challenge. Okay, now we're going to multiply 2x through everything, so that's going to give me 8x cubed plus 24x squared plus 18x. Then we multiply 3 through 12x squared plus 36x plus 27. Collect like terms.
Wait, can you wait for
I don't usually wait for pre-calc.
36.
Just kidding. Yeah, there we go. She's got it. 36x squared plus how many x's?
54.
54x plus 77.
Yeah, she did. So then we can go ahead and find the derivative. I guess I shouldn't say that. Pedro helped you.
30.
24x squared plus 72x plus 54, and the 27 goes away. Done.
No,
Excuse you.
Choose yourself. You're so sassy.
I am. It's probably because I'm sleep deprived.
Are you
I don't drink coffee, but I am drinking chai tea. I literally fell asleep this morning. I like sat down over there for a minute, and then Miss Blair woke me up. All right, so you guys are done because you're talking too much. Leibniz was the first of the two great calculus developers to use the chain rule to differentiate composite functions. Let's write a rule together. So if f of x is equal to g of h of x, in other words, composite function, then f prime of x is going to be equal to g prime of h of x times h prime of x. Now, what's an easier way to say that? or help you remember it. This is the derivative of the outside times the derivative of the inside. That's the way that you're probably going to remember this one, right? Derivative of the outside times the derivative of the inside. Okay? Does that kind of make some sense? No, wait? I don't understand. Is it no or wait? Oh. But you're not even here today. I already marked you absent. Alrighty. So that means we've got to do the same problem using chain rule and prove that they're the same, right? Guys, watch this one. You're going to like chain rule. You're going to like it. You're going to like it. All right, so let's take a look here. If we think about this here, let's think about what our two functions are. So the outside function we said was g. So in this case, g of x is really going to be like something, let's say c, I don't care, cubed, right? Like the outside function is something cubed. Do you see that? Something is cubed. Yes, that's the furthest outside of the function. Good. Now, that means that g prime would be equal to 3c squared, correct?
Yes.
Good. Now, the inside function, which we called h of x, is whatever's inside. So in our case, 2x plus 3. And the derivative of that is nice and easy. What is it? 2. Love it. Excellent work. Okay. So now we can go ahead and try and apply this thing, right? So f prime of x is going to bring down the 3. And what is c really? C is actually like h of x, right?
2x plus 3.
So exactly 2x plus 3 squared, right?
Y squared.
Times, because that's the derivative of g of x.
Yes.
And then we're going to multiply by the derivative on the inside, which is just 2. So this thing is literally just 6, 2x plus 3 squared. Done. Didn't I tell you were going to like chain rule? Look how fast that was. Now, for the sake of making it the same as the other one, let's quickly go ahead and expand this. So this would be 4x squared plus 12x plus 9. Then we multiply it all by 6. 24x squared plus 72x plus 54. Hey, look at that. Samesies. But most of the time, you're probably going to leave it in that simplified form here.
Where did you see that?
Right here. Bam. Right? So it's the same thing. We proved that it worked. All right. I know, me too. I'm freezing today. I cannot get warm. So we're going to find the slope of the normal line of the graph of blah at a specific value of theta. So in order to do that, I'm going to need to do the derivative, and then I'm going to find the sine, and then I'm going to do the sun. Exactly. So first thing I need to do is find f prime of theta. Now, what is the outside function? What is the thing on the furthest outside? Is it? Well, it's the squared, right? Because remember, this could be written like this, where the whole thing's squared. Okay? So it's going to be 2 times sine of theta times the derivative of the inside. What's the derivative of sine? Just cosine.
Sorry.
Yeah, it's the other way around. The derivative of cosine is negative sine. All right, look, we're done. Don't you like that?
No, wait.
Isn't that nice?
That derivative of the outside.
Outside times the derivative of the inside.
That's it.
That's it. Chain rule's amazing.
And is that just what we did it
I mean, we're going to find it at 3 pi over 4, but yes. All right, so 2 times, what is the sine of 3 pi over 4?
What?
What quadrant is that?
3 pi over 4 is second square.
Second quadrant. So is sine positive or negative?
Todos sentimos positive.
Square root of 2 over 2.
Perfect. And cosine in that quadrant is?
Negative square root of 2.
Perfect. Then we just multiply. Well, I guess we might as well cancel out one of these 2's first. All right. So root 2 times negative root 2 is negative,
Root 4.
which is
2.
2. Absolutely. Over 2, which is really
Negative 1.
negative 1. All right. But we're not quite done, because remember, that is f prime of 3 pi over 4.
You need to find the normal one.
So then when we find the sun, it's going to be 1.
We'll have
Well, technically, if it's negative 1, it's going to be 1 over 1. But that's just 1. So let's just write 1. Feel good? Any questions?
I love finding the song when I know the song.
Oh, no. It's kind of fun. Alrighty.
Wait,
Wait, mister. What's my name?
Mr. Brad.
Braddy. Braddy, Mr. Bradford, Mr. Brad. Just not
Mr.
Mr.
Brad.
Mr. Brat? I would even accept that.
Brad.
Mr. Brat. Hey, no.
It's not a phone.
I took it as one, so sucks to be you. Tried to insult me and failed. I'm sorry, that was
I
too
don't
sassy.
care about You're very sassy.
I am today.
No.
All right, we good?
He's not sassy. He's
Just
nasty.
today. I'm not always sassy.
You're always sassy. You're not always sassy. Sometimes you're sassy, sometimes you're nasty. For example, today you're being nasty.
No.
Today you're sassy.
No.
But I believe the first classes you were sassier.
That's fair. I'm sorry.
You were straight that first class.
You told us to go out of that like
Emilia was scared of you. We would come in
All right.
cafe and she would be like, "We're gonna be late," and he's gonna shut the door and he's not gonna let us in. And I was like, "What?" I was super scared of you.
But I don't do that.
How are
I'm
you
sorry
so
you're scared.
cold in a turtle?
I don't know. I'm free because I didn't sleep. So I'm in a turtleneck and a sweater.
Everything. Maybe you should get better sleep. 'Cause
Well,
not everything.
did you miss the part where my 3-year-old has been up all night?
I know. Yes, I did.
Okay. So let's do this. Outside function is what?
3.
Something cubed. So therefore it's 3 times the original function
Where?
squared times the derivative of the inside. What's the derivative of the inside?
6x.
6.
Look at that. Isn't that like we're done?
I said it.
I mean, if we wanted to, we could put like 18x, which is probably a good idea. We should probably put everything out front so that we don't like make a mistake. But like, look how easy that is. Okay, this one. Now, guys, you probably want to rewrite this first. So I'm going to rewrite this and say, hey, this is 2x plus 5 to the power of 1/2. Because that's easier to see the outside function now, right? What's the outside function? 1/2. So this is going to become 1 over 2 times that original function, so 2x plus 5, times,
We don't put on exposure.
sorry, yeah, negative 1/2. Thank you, there we go. Times the derivative of the inside, which is 2. And then that cancels the 2's, right? And what happens to that one with the negative exponent? Usually we just write it with a positive one, so 2x plus 5, and it's a square root. So let's
I
just do
don't
that.
know when to cancel things.
Well, if you had 2 over 2, it would have still been the same answer. It's okay. Does that kind of make sense? Guys, you're probably going to get pretty quick at doing the roots where you're just going to slam it straight to the bottom anyway. Because, I mean, if I've got square root, I know that it's going to be a square root again, but on the bottom. Right? If I have a cubed root, like the next one, it's going to be a cubed root on the bottom that's also squared.
Sir,
I'll explain that as we do it. Yeah.
like on the next on an exam, like here we are like leading it like very simple. On an exam, we need to like simplify the most we can.
It depends on the question. But I mean, this one, yeah, like you can't simplify that further. That's why we like chain rule.
Yeah, but for example, the first one, we should simplify on an exam.
Yeah, usually, yeah. All right, let's rewrite this one first. So this is really x plus 2 to the power of 2/3, right? Because it's squared and cubed rooted. Okay, so that means that the derivative is going to be 2/3 times x plus 2 to the power of negative 1/3 times the derivative of the inside, which is 1. So that doesn't really matter. So this is really just going to be 2 over 3 times the cubed root of x plus 2. And like I said, if you get like more familiar with these, it's totally fine to go straight to this step. Because realistically, if you know it's going to have a negative exponent, you might as well just throw it on the bottom right away. Okay? Because usually you're going to write things with a positive exponent. All right? Go! All right. Then, same thing, guys. Anytime you see something with a root, until you get good at them, I recommend you rewrite the equation, okay? So this is 5x squared plus 2x to the power of 1/3, right? So now it's a whole lot easier for us to try and take that derivative. This 5 is still there. It's just like the 5, right? So there's a 5, and then the 1/3 comes down, so it's going to become 5/3. Are we all okay with how 5 times a third is that?
Yes.
Good. Then we're going to take this. Now let's see if how good you guys are. I'm going to extend this out, because if this is going to be the exact same thing to the 1/3 minus 1, what's the new exponent going to be? Negative 2/3. So instead of writing it on top with negative 2/3, we're going to write it directly on the bottom with that 2/3, but positive, right? Because we took care of the negative by slamming it on the bottom. Does that make sense? Right? Because if we're going to have to write x squared plus 2x to the power of negative 2/3, because 1/3 minus 1 is negative 2/3, rather than writing it there and having to rewrite it on the bottom, we're just going to put it on the bottom. Okay? Now, what's the derivative of the inside? Because we also got to multiply by that. 2x plus 2. And I'm going to put that directly into this fraction because I could write like times 2x plus 2, but ultimately if we're multiplying fractions, it's just going to end up here. Now, why would I do it that way? Because now it's nice, neat, pretty, and simple and done, right? That's it. That's it. Nothing. It's totally correct. Like if you wanted to write times 2x plus 2 over here and not write it here, it's the same thing. I just think it's easier to do it over here. And I'm going to erase this so we don't get confused by it as well, right? Because that was just our side work. There we go. Look how good we are. I mean, in this case, guys, I guess, hey guys, as per Pablo's question, like, I guess you could simplify the top here and you could write like 10x plus 10 over 3x squared plus 2x to the 2/3. But I'm not sure that's really helpful. Paulina. All right. So I don't know if that's actually helpful. So you can do it or not. Sometimes you're going to have to. If it's like a multiple choice, they're going to give you the simplified, then you have to.
And if it's not multiple choice, I can give it on simple.
Yeah. Well, we already wrote that one.
Wait, I have a copy.
What were you doing then?
No, but analyzing.
No, you were talking to Paulina. That's what you were doing. See? Sophia's in trouble, I told you. And I still named my daughter one. And she is, man. Huh?
They forgot they're not having anywhere too.
No, we're done. We were done at 2. And then we had 3.
You wanted how many?
I don't know. I always wanted minimum 2. And then when we had 2, we were kind of done.
I want one. And then
I'll tell you why later. I'm not going to tell you why on a video. So
I want 1 or 3.
I don't want to immortalize that. Okay, so guys, this one's a little bit tricky. I want you to look at this.
What?
Guys, you should pay attention to this one. Pertus. Emilio, you guys are going to be screwed if you don't pay attention to this one, okay? Pay attention. We're going to switch things up a little bit here. So if we look here, what is the outermost function?
3x. 2.
It's something squared, right? So we'll just call it c squared. Now, what is the middle function? Oh, I'm messing with you.
3x.
Cosine of 3x.
Why you put middle?
What's the inner function? 3x,
Wow.
right? Because remember earlier when we first did trig, I said actually technically they're all composition of functions, but we've always done it where it's just the trig function of x. And what's the derivative of x? 1. So you didn't have to know chain rule because it kind of took care of itself. Now you're not going to be able to do that. So let's do these. And actually, let's do this below. G prime of x. That looks like a 6.
That would have been great if before I wrote it in pen.
Well, just scribble it out like I did.
No.
All right, so the outer function is going to be 2 times cosine of 3x. Technically to the power 1. Then we're going to multiply by the derivative of cosine, which is negative sine of 3x. Then we're going to multiply it by the derivative of what's inside, which is 3x, so derivative is
3.
Now, guys, put all that stuff in the front. So I'm going to get negative 6 cos 3x sine 3x. Okay? I always recommend you put all those coefficients up in the front because if you don't, it's just common that students make mistakes. So I would throw all of them up front. Okay? Huh? Because I had to multiply by the derivative of the innermost function. Right? Because we're doing a double, this is a double chain rule.
If that's double by double.
Because there's three functions inside of each other. So this has to, that means we have to do double chain rule.
3 times x is not a function.
That is a function. 3x is a function, cosine's a function, something squared is a function. So we got to do all of them. All right, so as per the question while paused, why did I switch it? Because I don't like writing capital G's. It should technically be one. No, it's not bien. He's busy. All right, it's his choice, but he's missing class. All right, so outermost function is what? Something squared. So 2 sine of 2x plus 1. What's the derivative of the middle function? The sine.
Sine 2x plus 1.
No.
Minus cosine. No
Cosine of 2x plus 1. And then what's the derivative of the innermost function, the thing inside the trig?
2.
Just 2. Now slam that all to the front. In this case, it's just going to be 4 sine 2x plus 1. Not times, that's inside. Times cosine of 2x plus 1. You said times 2x plus 1, but it's not times it, it's inside the sine function. It's inside of it.
But you also said times.
Well, 4 times this. Did I say time? Whatever.
I don't know.
I said it here and here. Oh my gosh, we're getting her mad.
Times. The big three.
Are y'all ready? You all know the big 3.
Can we make it product, quotient?
Okay, really. The big 3, product, quotient, and chain rule. We're going to look at doing multiples of them. So we already did one question where we did product and quotient rule. What is this one going to be? What are the 2?
Chain,
Chain and
quotient,
product, right? There's something multiplied and there's a chain rule because there is a square root. So we could think of this as really being 5x times x plus 3 to the 1/2. Okay, so let's go ahead and do that now. So f prime of x, derivative of the first is 5. Second function stays exactly the same. Plus the first function times the derivative of the second. So it's going to be 1/2. And instead of putting x plus 3 to the negative 1/2 on the top, where could I put it? It's going to immediately put it on the bottom, right? Because it just makes my life easier rather than writing x plus 3 to the negative 1/2 on top. Now, I do need to multiply by the derivative of the inside here, which thankfully is pretty easy. What's the derivative of x plus 3? 1. So I technically multiply this by 1. Okay? Where this part here, that's the chain rule. And then the whole thing together is the product rule, right? All right. So let's simplify this a little bit because I don't think we would leave it like this. This one's pretty messy. So this is going to be 5 times the square root of x plus 3 plus 5x over 2 square root of x plus 3. Now, guys, I'm not going to lie to you. If you see something like this, you are almost never going to leave your answer as 2 fractions. So I would need to get this one to be a common denominator, right? So I need to multiply this whole first fraction here by 2 square root x plus 3 over 2 square root x plus 3. Right? Now, if I do that, now I'm going to have a common denominator. So the whole thing is just going to be over 2 square root x plus 3. But what is 2 times 5 first?
10.
And what's square root x plus 3 times square root x plus 3?
X plus 3.
Exactly. And then just plus 5x. And then my last step is going to be to, well, not last, I guess, second last. I'm going to put that in. So 10x plus 30 plus 5x all over 2 square root x plus 3. What's the final step? Combine the x's. How many? Good. 15x plus 30 over 2 square root x plus 3. So, like I said, sometimes I'm going to do this to help you like practice doing the algebra. Sometimes we won't. But in this case, with its two separate fractions, you're almost always going to need to rewrite that as a single fraction. Multiple choice, you're going to do it. Written, you should do it, or you're going to specifically be asked to. All right. What is this one going to be? What are the two that we're combining here?
Chain and quotient.
Chain and quotient. Chain because it's a trig function. All trig functions are automatically going to be a chain rule, and then there's a quotient inside. So g prime of x is going to be the derivative of the outside, which is just going to be sine. So it's cos, yes, the derivative of sine, but yeah, it's cos. Cosine of my big mess. And then I'm going to multiply it by the derivative of the inside. I'm going to use a nice big bracket here to write it out because I need to do a quotient rule. So low d high, which is 2, minus high d low all over low squared. I feel like there's some things that are going to simplify, so we should probably simplify this one at least a little bit, because there is definitely some stuff that's going to cancel out there when I'm looking at it. Because here I'm going to have 2x minus 2x, right? You guys see that, or do you want? Let's work it out. 2x minus 6 if I put this 2 in, and then I'm going to distribute the negative, so minus 2x minus 1 all over x minus 3 squared. Now the reason I'm doing that is because now there's a few things that are going to simplify there, right? So what's 2x minus 2x? Yeah. So we write the first part, cosine of 2x plus 1 over x minus 3. And then we're going to multiply that by 2x's cancel.
So it's 5.
And then we've got negative 6 minus 1, negative 7 over x minus 3 squared. Okay, and now at that point, I would probably just leave it like that, because you can't really do much else that's going to, or you can't really do anything else that's going to be helpful. I guess technically this should be g prime as well. Awesome. All right. Oh, sorry. So the next one, what did we do? We did chain and quotient, chain and product. I don't know. I don't remember.
So it's gonna be product and quotient. No.
No, it's chain and quotient again, but in a different way.
What?
Chain and quotient again.
How?
So let's rewrite this as 2x plus 5 to the power of 1/2 over x minus 3. So the first thing I'm going to do is going to be quotient rule. So that's going to be low d high. Now I need a chain rule. And technically, since we're getting good at this, if I'm going to subtract 1 and it's going to be negative 1/2, let's just put it on the bottom right away, right? And then the derivative of the inside, 2. So I'm going to put that on top, which is great because some stuff will cancel. Minus high 2x, because that's the derivative of the inside, right? Derivative of 2x plus 5 is just 2. Oh, you mean why didn't I put it out here? It's the same difference. I like to just simplify them a little bit as we go. Times the derivative of the bottom, low d high minus high d low, which is 1, all over x minus 3 squared. Now, realistically here, the 2's are going to cancel there. We should probably combine these, so this is going to be x minus 3 over the square root of 2x plus 5. Now, this one, I should probably get a common denominator, right? So this is currently over 1, so what would I need to multiply it by?
What?
Yeah. Square root of 2x plus 5 over the square root of 2x plus 5, all over x minus 3 squared. I did that because now these have a common denominator. I can put them together. What is this thing times itself? What's any square root times itself?
1.
2x plus 5.
Exactly. Now be careful here. I would put a parentheses around it so you don't mess up with that negative, okay? And it's over the square root of 2x plus 5. Now, realistically, if I'm doing like divided by a fraction again, how do I divide fractions by fractions?
Change flip.
So I'm going to keep the first one, change it to multiplication, and flip that one, right? So instead of putting it like fraction of fraction, we're going to simplify it. Now, can I simplify the numerator? What can I do to the numerator there? What's x minus 2x?
Negative x.
Yeah. And what's negative 3 minus 5?
Negative 2.
Not quite.
2.
Negative 8. Heard somebody say it. All right. Over the square root of 2x plus 5 times x minus 3 squared.
You can subtract something that is inside a parenthesis. It's going to be divided by itself.
Yeah, because I mean, technically, what would I do? I would distribute this negative 1 to get negative 2x minus 5, and then I would just collect like terms. So, yeah. Good. Any questions about that one? Guys, if this part of the algebra is giving you a hard time, you need to go review pre-calc. Okay, because this is like a really common thing that you're going to need to do for the rest of your mathematical lives. Right? When you have two fractions, you need to be able to get a common denominator and put them together. Okay, so if that's the part that's giving you a hard time, come see me some other time, or review it on your own, or however you want it. All right? Okay, so given the graph of h of x, which is pictured, find the equation of the tangent line of p of x when x is 4. So p of x is the square root of h of x. So let's start
Or h of x.
by just finding p prime of x. Because if I'm doing the equation of the tangent line, I need pot and sod, right? So I guess I could have done my pot first. Let's do the pot first. That's usually what we do, right? And then I just plug it in. So it's going to be h of negative 4, right? Because p of negative 4 is going to be the square root of h of 4. So h of negative 4 is right here.
So 2.
So it's 4, which is going to be 2. Exactly. Do you guys see how we got 2? Right? Okay, good. Now we need to find the SOT, so I need my derivative. So this is going to be 1 over 2 square root h of x. 1 sec. Times the, here, well, we can do it out here since you guys don't seem to like that. Times h prime of x. Okay? This is just like our, square root of something. And then we got to multiply by the derivative of the inside, which is h prime. I mean, go for it.
No.
Oh, okay. So now we'll find p prime of negative 4. Now this one we already did, right? What was the square root of h of negative 4? It was just 2. So this is going to be 2 times 2.
1/4.
Now the derivative means that we need the slope. What's the slope of this line? Negative 1/2, exactly. So it's going to be negative 1/2. That's h prime of x, because it's just the slope of our graph. And because it's a line, we can do it. Guys, this is real common. We're going to give you like a line and then ask you for the derivative because you can find it. Okay? All right, so this is going to be negative 1 over 8. Okay, so it's going to be y minus 2. Sorry, I didn't write that down. That's my SOT. Negative 1/8. Okay, so y minus 2 equals negative 1/8 times x minus negative 4 plus 4. And that's the equation of my tangent line. Yeah? Yeah?
Yeah.
All right. Guys, we got one last table question and then we're done. Because that way on Thursday, on that awkward day, we can have a flex block. Yeah.
So we got it there by just eyeballing
Eyeballing what?
the slope.
I mean, technically you eyeball it, but I mean, if you have a graph, it's just like negative 1 over 2. So rise of negative 1 over 2. All right, let's do this one. So we've got differentiable functions, f and g. And then we're going to got a bunch of values and we're going to see if we can understand it. So the graph of h of x is f of g of x. We want to know if it's increasing, decreasing, or at a relative max or min when x is 3. So first thing is find h prime of x. What is this? Product, quotient, chain. Chain rule. So it's going to be f prime of g times the derivative of the inside, which is g prime of x. Then I'm going to go ahead and plug in 3. So it's going to be f prime of, what's g of 3?
4.
4 times g prime of 3. Okay. So then I need to find f prime of 4 times 6, which is 48. Now, if it's 48, what does that mean about the original? Is it increasing, decreasing, max, or min?
Increasing.
Good. So, oops, h, not h prime. H of 3 is increasing because h prime of 3 is positive.
It would be max or min when.
If it was 0 and then it was changing signs. Yeah. All right, let's take a look at this next one.
Like how would we know if it changes sign?
You do the sign analysis where you plug something a little to the left and right. Yeah. All right, so first is we're going to find p prime of x. So the derivative of the outside is going to be g prime of 2x times the derivative of the inside, which is 2. So p prime of 1 is going to be, let's write it this way first, g prime of 2 times 1.
Why?
I'm just writing it with an extra step for you every once in a while. So what is g prime of 2?
-1.
Wait, I did that wrong. There we go. There we go. All right, so negative 2. B prime of 1. Go ahead. Any questions about that one?
No.
We feel good? I think I'm going to have to do another video.
Whoa.
Oh, sorry. That's why I asked if you have any questions if we're good. All right. All right, so q of x is going to be this monstrosity. So it is a chain rule, right, if we look at it. And we need to find q prime of 4. And what does that tell us about q of x at 4? So increasing, decreasing, max, min, etc. Yeah, which question?
No, you're
Oh, okay.
it's a chain.
Yeah, exactly. So let's start out. So it's going to be 1/2 times f of x plus g of x to the power of negative 1/2.
Why don't we put it in number?
We can. This one's going to take a little bit of rearranging anyway. So times the derivative of the inside, which is just f prime of x plus g prime of x. So let's put that all together. That's going to be f prime of x plus g prime of x over 2 times the square root of f of x plus g of x. So there's our cleaned up derivative. Okay. Now we got to find it. That looks like a 4 already. Let's make that should be an x. Okay, so then q prime of 4 now. So f prime of 4.
8.
8. And g prime of 4?
-2.
Negative 2. Is anyone else looking at him to check to see if he's right? Because I can't see it anymore.
It is.
He's right?
Yes.
Okay, good. Over 2 times the square root of, what's f of 4? 1. Plus g of 4.
7.
What is that? One in a parenthesis.
It's just an ugly 1. Sorry. There we go. Then we can simplify that, of course. So 8 plus negative 2 is 6. This is going to be 2 times the square root of 8. Now, you might try to leave your answer like that. That would be a bad idea. So first of all, I can simplify this a little bit and make that a 3, right? 6 over 2 is 3. Second of all, what's the derivative, or what is the simplified version of root 8?
1.
2 root 2. I heard somebody say it, right? Because we can split that apart into 4 times 2. Was it you? Okay.
And me.
And you? I don't know if I believe you, but okay. All right, so this is positive. Therefore, q of 4 is increasing because q prime of 4 is greater than 0. It is positive. Amazing, right?
We finished.
We did it, guys. Next block, you get to just work because it's before Halloween.